Warriors around, don't get caught in the mosh pit. Fuel to the fire, ain't nobody can stop it. Trouble in my city.
Can you give me what I need? Just give me what I want, baby. Can you give me what I need? Just give me what I want. Just give me what I want.
future. Evolution. This is the future. Evolution. This is the future. Human error. Evolution. This is the future.
G'day, g'day, g'day. Welcome to PowerShell 101 Live. I believe we're live. I just need to do a quick check. 2 secs. Make sure I can hear myself. Yep, cool. We are live. We are good. People can hear me, which is great. Yeah, welcome. Welcome to 101 Live. Oh, it looks like it's just hung. No, it's back. Cool. So today, testing. We are doing lots and lots of, we're going to be covering a lot of content today about testing. Testing's going to be a fair bit of content with regards to actually writing tests, but obviously understanding why we write tests, the concepts to understand about writing tests and all those kinds of bits and pieces. So first things first, welcome. Welcome if you're watching live, or if you're not and you're going to be watching the YouTube stream later. Yeah, g'day. Make sure you subscribe if you like the content. Testing. So as Glenn Satari, if you followed me on Twitter, literally pestered me with 255 characters of Pester. We will be doing a lot of Pester today. There is going to be a ton of demos. So come expecting demos. There's going to be lots and lots of demos. 2 secs. I need to stop a script. It stopped itself. I love it when it does that. I love when code just works the way it's supposed to and you don't have to deal with shenanigans. All right, so I'm just going to get everything squared away. So in the lesson plan today, we're basically just, what is software testing? Like, we're coming from a 101 perspective. I want you guys to kind of understand why we do it. What's the big deal about it? Why is this the industry's now just blown up with people want to see Pester on the resumes. They want to see Pester. They want to see software tests, the ability to write tests for their code. What is the big deal? Well, I'll quickly switch to the screen. I just totally forgot about that. So yeah, essentially, yeah, what's the big deal? We're going to be writing some basic tests. So we're just going to get the fundamentals of understanding the tests, things like that. And then we're going to have a bit of an intermission. We're going to be looking at parameterized tests, and then we're just going to be looking at refactoring existing code for testing. One thing I did forget to mention, within the software testing, we are going to be going through all of, like I said, the fundamentals. So we're going to be looking at the AAA framework. We're going to be looking at a good test, what this constitutes as a good test versus a bad test. We're going to be looking at a whole bunch of different scenarios with code coverage, all these random things that you're going to hear within the testing community that basically help you understand and be able to articulate what's going on there. We're also going to be doing, we're going to be talking about the 3 basic types of tests, unit integration and end-to-end testing. This specific this specific lecture is just going to be focusing on unit integration testing, mainly unit testing, because you can learn the fundamentals, and then from that you can basically just work with what you have. So, yep. So, from that, we then basically going to be writing tests. We're going to be refactoring code and doing lots and lots of cool stuff. So, lots and lots of demos. So, you guys, if you have questions, don't be afraid to interrupt. I don't really mind. I think the audience, I want you to guys ask questions now, because it means that if you're asking questions now, you're going to get a direct answer, when obviously having to wait for a YouTube comment or something like that, that's generally going to take time. I generally don't check my YouTube comments that often. Anyway, so some homework, like I said, always some homework. So if you obviously have been following this entire series, we've been focusing on automating various things. So in this instance, we've just got a single task for you guys to do, which we've covered 90% of this in the course. The final part we haven't done is installing Visual Studio Code or installing OBS Studio. They can be done fairly easily, but essentially you just need to, using Client Hyper-V, install build a VM, install Windows 10, install OBS Studio version 24. I think it's like at version 25 now or something like that. I literally lose track of versionings. And then install Visual Studio Code. So essentially, that's just going to help you guys articulate what's going on and help you to write some basic automation. It's really about just getting you guys in, writing some very fundamental level automation, and then from that being able to actually scale up onto the bigger stuff. So software testing, what's the big deal? Why is everybody just raving on about it? Let's get stuck into it. One of the things I want to do is, if you guys are familiar with C#, this is the course I did. I actually went and just did a course from this guy. This guy code with Mosh. He actually has a YouTube channel. He has a free version of it. I literally watched the free version of the YouTube video. See if I can find it on C#. It's really good. He's a really, really excellent teacher. I just went and watched his YouTube video because, and then from that, I then actually went and bought his course because it was really, really, really good. I thought it was excellent. It taught a lot. So this is the guy here. He did one with C#. So he's got obviously MySQL in a couple of hours. He's very, very, very good. Very good full stack developer. Where is he? Let's see if I can find the one that I was looking at. React. Where is he? Unit testing. This one here. I'm just gonna watch it on YouTube. So essentially, you can see it's a 44-minute. It's a 44-minute video, but if you buy the actual version, it's about it's well over 4 hours worth of content. So you do get the brief understanding of what's going on here. This is a really good start to get you familiar with it. But essentially, yeah, if you want to get the full experience, go watch that. It's really good. But anyway, that's just a really good course. It's going to cover a lot more than what I'm going to be covering, because I've literally only got a 2-hour window, where he's obviously got a lot more content that he provides. So yeah, go check it out. So what's the big deal? What is a test? What is the big deal with it? So a test, essentially, we'll talk about what a test is first. So a test is basically just an investigation that's conducted by a stakeholder about the quality of a product. For instance, think of it as what you're doing is you're just testing your code for any sort of bugs. Automated testing really comes into its element, especially when you're working within the DevOps community and you're basically within a software development pipeline. And so basically, if you're pushing code to your different repos and you basically have specific builds set up on your pipelines, that will go through and run tests. These tests will basically validate the quality of your code and if any adjustments that you've made to a specific piece of the code to make sure that it's up to scratch. There's no sort of outstanding issues there. You can write tests for pretty much anything. I've recently just come off the back of a project which is at work, which basically we can write templated code. So essentially it's a module that I can deploy to our internal machines that basically is a PowerShell module which allows you to just write, you can run a commandlet and it'll basically build out a nice templated code for you. That's all controlled through build pipelines and it's run through tests. So when I make changes to that module, it actually runs changes on that tests and things like that. Those tests are generally, it does a variety of tests. It does code quality tests. It does unit tests. It does spelling checks, I think. It has a whole bunch of different things you can do with it. So it's not just limited to just unit testing, integration testing, end-to-end testing. You can do chaos testing. You can do other things. So, but for this specific lesson, we're just focusing on those specific three, which is unit, integration, and end-to-end. Mainly unit integration. But the main thing is that this testing allows you to be able to validate your code in specific scenarios. So whether those scenarios are super extreme, so let's think of it as you've got a website that you're hosting and you need to validate that it can be able to serve 10,000 concurrent users, things like that. Those are the kinds of tests that you can write. Obviously you can write unit integration tests and things like that, which we'll cover, but essentially you're just checking your code. You're making sure that it stands up to scrutiny. It's important because at the end of the day, though, tests ensure that your code it has quality to it, and that basically you're essentially having a stable platform to work on. So if you basically have code that's deployed out in the wild and you have tests associated with it, you know that your code is up to scrutiny. And then other people, if you have a publicly available repo and people can see the tests with it and they can see your builds, essentially they can do the same thing. So a good example is for this, in this instance, is think of it, you have two PowerShell modules. Let's call them logging 101 and logging 102. Both modules are literally exactly the same. They have slight variance in terms of code logic underneath, but essentially they perform the same function. They're just writing a log. Well, let's assume for the specific sake, they're writing the exact same type of log, the exact same format, so there's no difference in terms of logging if per se. Now, logging 101 is really well rated on the PowerShell gallery. Let's say it has 5 stars on the PowerShell gallery. It's got 1,000 5-star rating, so it's really popular. But then you have logging 102. Now, logging 102 doesn't have that many ratings, but it has unit tests with it. And so you can see the unit tests where logging 101 doesn't. Now, which one would you choose if you were to choose a specific module? Would you choose logging 101, which has a really good rating, but it has no unit tests? Or would you choose logging 102, which doesn't really have a rating, but it has unit tests? Which one would you choose? I'm going to give you guys about 10 seconds to kind of think about it, and then if you're logged into Twitch, chuck it in the comments. Which one would you choose? Okay, so personally, I would actually choose 102. Now, ratings are good for logging 101. Ratings are excellent for 101. But what happens if that author introduces a breaking change into that module? So he's just deployed a new module update. It's got some I don't know. It's handling locked files on the file system, for example. Except for some reason, there's a logic error with it. He's got a logical bug within it that does some random stuff. I don't know. But essentially, because there's no actual unit tests, that change will be pushed to the customer, which, okay, the customer's getting it for free, admittedly, but at the same time, though, if you've got so many users that are relying on your product and you haven't actually deployed a module, or you don't have tests to validate that, essentially what you're doing is there's no faith in that. And then basically there's going to be no faith in the build pipeline, there's going to be no faith in anything. So essentially what will happen when those users get that module, that's going to break their production code. If they're relying on that module for their production code's going to break, everything breaks. Now, obviously, if everything breaks, you're in a really kind of a bit of a sticky spot. And what's going to happen is those users will generally transition from that specific 101 module to 102. So 102, having tests is really important, because if let's say the guy in 102 makes a release. Now, in his release, he has a build pipeline and he is running unit tests. What is actually going to happen there is that basically it won't get pushed to the customer. He'll see he has a breaking change to his module, and therefore he's not going to push to the customer. So as a customer, you only get the quality code, you don't get bugs. And that's essentially what really testing is doing. It's basically really making sure that your code is up to scratch before it goes out to the customer. And so this is reason why it's very important. So let's actually now quickly go and have a look at what some people say about testing. So I kind of just made this bit of a slide. These are some things that I've always heard that people talk about testing. These are generally, and I legitimately, these are what I've heard people say about tests. And it kind of worries me with some of them, like, I don't write tests, my code's awesome. This is something I've heard quite a lot. I've heard writing tests take longer and it's not cost effective. So that's generally quite valid. Writing tests will take longer. I've heard people saying I only use the test-driven development approach to writing tests. I've heard people saying I write tests after I write my code. And then I just hear people just saying it's a waste of time. So these are things that I will say to those to kind of counteract it. So it only takes a moment for that person who says I'm awesome, I'm completely awesome, I write amazing code. It only takes one moment to lose trust. And that can be one break. So if you think back to logging 101, it takes one bug to completely break a module that basically will break production code, and that will break trust. And if you break trust, it's going to take an eternity to get that trust back. So testing is really important for those kinds of situations, especially when you're in production. You do not want to be introducing code that could potentially break production. Tests do take more time. So when people say, oh, it's going to take ages to write, you know what? It's true. It will take you longer to write tests associated with your code than it is just to write code and spit it out. And this is something that I know a lot of customers of mine, when I talk about tests, if they're wanting to pay for that, they're not fussed, because it's, why would I want tests? And it really comes down to prior preparation prevents piss poor performance. So if you're prepared beforehand, before actually deploying your code, before, thinking about it beforehand, you're not going to have as many issues. Now, admittedly, you're not going to catch every bug. There's always going to be bugs that are going to slip through the net. That's just a fact of life. But the thing is that you're going to basically catch a majority of those bugs, and that's the most important thing. There's going to be situations where you're going to be able to catch bugs in the most extreme environments where you didn't even think possible. A really good example of that would be, there was a time I wrote I had to use logging in combination with testing, but essentially I had to write a whole bunch of tests to test a very specific scenario for a PowerShell module. And essentially what happened was, you could have multiple PowerShell modules open, and it was talking to a REST API endpoint. And at that point in time, somewhere one of those 10 concurrent consoles with this module loaded interacting actively with the API, basically one of them might refresh the token. And the other 9 consoles needed to be able to, whichever one randomly had it assigned to it, randomly decided it needed to refresh the token, the other 9 consoles needed to wait for that specific refresh to actually occur, and then basically go and refresh their configuration to get the new token information. So essentially what's really important here is I actually had to write this crazy integration test to actually be able to go find that. And this is one of these things where it's really, really important to have that ability to be able to do that. Now I had to use it in conjunction with logging because the amount of data that I was generating was enormous. And so I did find the error and I found the bug, and essentially then was able to test and patch it. But then I had this integration test, which then I could add to my pipeline, which was critical for the success of the module. So essentially I had this module now that I could basically run this specific integration test to validate that there's no bugs in the code that could potentially affect a token refresh. So if the code basically, you had 9 concurrent consoles, and if the code decides to break, then obviously the build's not going to proceed. So these are the things that's really, really important why testing takes longer, but prior preparation prevents piss poor performance. You hear it's such a cliche to hear, but the thing is it's true, especially with testing. When in response to the people saying it's not cost effective, it's not cost effective in the short term, but it's cost effective in the long term. You do save a lot more money because once the test is written, it requires little maintenance. And once the test is done, you then know that basically that test is done. If there's any changes to that specific piece of code, you can just run the test. You don't have to manually have a tester to actually do that. So that's really important with why testing is so important. And the final one is whether you write tests, whether you use test-driven development, whether you write test after. I've used test-driven development approach. I've written test after. Just write tests. The whole premise is just write tests. Don't care about which approach you're using because there's various approaches to do specific things and they have their advantages and disadvantages. The key thing here is to understand it's just to write tests. It's better to have a test than it's to have not a test. It's better to have a bad test than to have no tests. Slightly better, but essentially it's better to have a test than no tests. All right. So there's 3 basic levels of tests. Now we're not going to go through all the different types of tests because we'll be here all day, and I don't particularly really think you guys are going to be able to stay here all day to do that. But essentially we have 3 types. We have unit testing, we have integration testing, and we have end-to-end testing. So unit testing, essentially what you're doing is you're testing the process of the code from an aspect in an isolated environment. It's free from external references. So for instance, you're testing a function that involves an SQL query, but you're not going to actually connect to the SQL server as per se. You're going to mock that. You're going to basically emulate the connection to the SQL server, and you're going to emulate its response. What you're more interested in testing is the actual code execution itself and the output. So if you feed it 1 + 1 and you get 3, well then something's not right. If from a simple perspective, if you have a function of 1 + 1. So if you feed it 1 + 1 and you get 3 back, then something's not right. You're not interested in testing the third-party dependencies because at the end of the day though, unit testing is really focused on performance. All you're trying to do is just make sure, hey, is this code up to scratch? Is it performing? Is this function performing the correct output? It's performing the correct code execution when I'm actually providing it with its input. Integration testing expands on unit testing. Integration testing is now you actually can interact with those external third party or those external references. So for example, you've got your SQL server. Now, you might be actually interacting with the SQL server to go talk to a test environment, and you have test data in that SQL server. Integration testing is more focusing on the same quality of code tests, but essentially you're expanding it and you're catering for other issues like, network intermittent issues, things like that. That's really where integration testing is kind of branching into. And then and then you have the more extreme forms of that, and that could be chaos testing and all those kinds of things where you're having multiple tests running and trying to bring down a web service and things like that. But essentially, integration testing and unit testing are basically the two really fundamental tests for a software developer. Now, unit testing, integration testing, you generally write as a software developer. End-to-end testing, you don't. End-to-end testing essentially is the click test. You basically have a website, you're going to that website and you're emulating the clicks. You manually logging on. Think of it as a bank. You're manually, actually a bank's probably a bad example. Think of it as Facebook. You're basically scrolling up and down. Does the feed load correctly? Yeah, you type in a comment. Is you typing those comments in correctly? Pressing enter. That's basically using tools like Selenium and things like that to actually be able to emulate those kinds of functionality. But essentially, that's an end-to-end test. You're testing the actual user experience. Usually those kinds of tests are done by testers themselves. They're basically there's actually a complete job for that specific role. As software developers ourselves or as scripting within PowerShell, our job is to actually write unit and integration tests. Now, sometimes testers might want to write integration tests, but really when push comes to shove, unit testing and integration testing is what we do. And it's our responsibility because we know the code. It's important. Once we know the code, we can then write the subsequent tests. Now, I quickly talked about mocking in unit testing. So, what is mocking? Why do we talk about mocking? What's the deal? Mocking really is simply put, it's you're just basically emulating behavior. This is the GitHub. This is the GitHub quote. But essentially, what you're doing is, when I mentioned before, let's go back. We'll take one step back. When I mentioned before in the unit testing, I want to test that SQL function, but without actually reading it. You use mocking to emulate the functionality there. That's all it does. You're just emulating the functionality, whether that's a file system write, whether that's, a commandlet, whether that's anything, a module. What you're doing is you're mocking. You're just emulating that specific instance. And once you're emulating that instance, then basically you can then run your test. You don't care about the test data because the test data is test data. Who cares? It's test data. What you're interested in is the actual code execution itself. Is 1 + 1 going to equal 2? That's the key part. You don't care about the 1 + 1, you care about the 2. That's what you're looking for. So essentially, that's really what mocking is. Now, you can mock, so a lot of people might say, hey, well, hang on a second. If you're querying SQL data, well, how can I mock that? So you can manually mock it by constructing the object itself in the code, which is a bit funky. Or you can actually just import, you can use JSON or CLI-XML or XML to actually import it. Or let's say CSV file. If you have production CSV file of, you're taking an input of a CSV file of usernames or passwords that you need to reset, you might just have a test CSV file that you go and run an import on. And what you need to do is you can then use that test CSV within your project itself as your test. The data is good because the data is what you've actually created as. You can use mocks to actually mock production data. So if you've got, like a file system structure on a production environment, you might use that to mock. So essentially the mock is really it's just emulating what you need to do. And it's good emulation. It's not bad emulation. So you're pumping it, you're giving it good data. Now, there might be an instance where you might want to put bad data in there to actually test, hey, is my error handling actually working correctly? You can do that as well. You can mock in bad data. But essentially, mocking is just emulating a specific behavior. That's it. And you're just basically saying, hey, I don't want to pump it. I want to use a substitute CSV file. So that's pretty straightforward. So we're going to get into the demos soon. So you guys just hang on for a little bit longer. We're going to be getting there soon. So now I want to talk about the AAA concept. So I've got a bit of like in the slide notes. Before I actually go any further, I keep forgetting to do this. I'm going to paste in the slides, so you guys can grab the slides and have a look at the notes that I've wrote. So there's lots and lots of detail there. Let me just quickly grab that before we continue. So it's just a OneDrive link. Oh, I just popped into a Discord channel. Whoops. Here it is. Here, you can just grab this. So I'm just pasting that into the chat so you guys can grab that. Feel free to jump on it, grab it. All that is, all the demos and that are in there, so you can just copy and paste it out. It's completely fine. I don't really care. Alrighty, so the AAA concept. So essentially, the AAA concept is the way that we basically position we position our code for tests. It's just basically a way we arrange our code for tests. So there's three things we need to do. We need to use the arrange. So arrange is essentially you're just setting up the requirements for a test. So this is usually the first step of the unit test for the application. You're going to arrange the test. Essentially, you're basically creating an object. You're instantiating an object. You're doing all the requirements that you need to do to actually get the test to. You're setting it up so that it can run. That's essentially what you're doing. So think of it as like you got your parameter block at the top of your script. That's where you have your constants, all those kinds of things. Essentially, you're just creating a scenario for you to be able to test to run. The act. Act is literally exactly what it sounds like. You're just basically running the test. This is really where the code execution is taking place. So essentially, you're invoking the code that you need to run the test on. You're capturing its results, those kinds of things. The final thing is the assert. The assert essentially is you're verifying the response. You're validating that what is being caught within the act component is actually correct. So you're asserting that a specific value is 1. So for example, let's just bring this down to a bit of a high level example. So in the arrange, let's say we have a math function. Within the arrange, you would have the arrange would be, you'd set up parameters for that specific function. The act would be obviously invoking that function, and let's say the function is 1 plus 1, and then asserting, we'll assert that because we're adding, the value should be 2. And so you assert that it's 2. If it's anything but 2, then you have a problem. That test has failed. There's something wrong with the logic of the code. So that's actually, essentially, that's really it. It's pretty basic. So we're going to write some basic tests. I've kind of taken you through the fundamentals of it. It's just a really high level 101. It helps you just kind of at least be able to articulate what's going on and be able to write some basic tests for your code. And that's really, really important for you guys. So let's actually go and get stuck into writing a basic test. I've just got to stop here. Now, one of the things it actually is really important is before we write a test, we need to make sure that our code is simple and it's maintainable. So essentially, from a coding perspective, we need to make sure that our code is as simple as possible and that it's basically able to be testable. We need to reduce our code down to the simplest form, separating our classes, functions, and objects. Large swaths of code makes it really difficult to test. So remember, keep it simple. It's really important to keep your code simple. Tests, if it's not, and it's not that simple, it's an opportunity to start refactoring your code. Essentially, tests need to be simple and not overly complex. You do not want to make your tests overly complex because it's the same thing. People don't want to test or don't want to write updates to a specific test if it's super complex and complicated. You want to keep it as simple as possible, and if you do it, future you will love it. So essentially, yeah. So what consists of a good test? It's always a tough thing to ask. What consists of a good test? I find this is something that it's generally it's very hard to actually Like, I find it very hard to kind of articulate and kind of condense it down. But essentially, you can kind of just think of it as a 4-step program where you have, it's got to be simple and concise, which we talked about before. You're testing the correct code path, and you have proper validation. So the first thing is, it's got to be simple to understand. Like we said, your inputs need to be simple. You're validating when you're inputting something. Use test as a string, or 1 or -1 or 1. Don't put strings that are crazy complicated, because as a person is reviewing the test, he needs to be able to understand that, hey, the test is, you just need to see, you need to see the most basic thing there. You don't want to see something common really difficult, because the person is just going to think, well, why is that there? If you provide something really basic like test, they know that it's a test. It's test. Concise. Actually, I'm going to backtrack 1 second as well. Your mocks need to be as simple as possible as well. Do not complicate your mocks. It just gets crazy hard to then follow the test. Your tests need to be concise. So essentially, you want to write a very basic test, a very concise test, to the point. Don't want to go over the top with all this extra stuff. You want it to be very concise. I want to test this functionality, I want to test this functionality, and that's it. If you don't need to test anything else, don't. Test the most basic that you need to. Now, you might want to write some extra stuff in there to test other facets of the code, or you might actually have more tests that you want to test to basically test other elements of that code. But essentially, your test needs to be as concise as possible. It makes it much easier to follow. Like I said, the code path. You need to make sure that you're testing the correct path. The goal is to test each of the code execution paths. And remember that each code execution path is its own test. Don't stick them all in the same test. It gets very difficult to manage. And then the final thing is, make sure you validate the output as the expected output. You can do other things with it as well, but essentially you need to make sure that you're validating the correct things. Don't validate off null. If it's null, then anything can be null. Make sure you're validating on an actual output value. If it's true or if it's false, that's completely fine. If it's anything like that, that's completely fine. But don't just say, okay, it's not equal to null. There might be times that you might need to use that because you don't care about the value, you just care about, hey, does it have something? Because, if you're writing an integration test, there might be some, there might be a variety of different things that could potentially be. So, hey, you don't care as long as it's providing as an output. That's completely fine. But essentially, if you're writing something that's just, okay, it's null for the, it's not equal to null, and it does have an expected output, that's bad. That consists as a bad test. So, yeah. Now, the final thing, which is really important, is you need to fail your own test. Now, this sounds kind of counterintuitive, but if you want to make sure your test is good, you actually need to make the input bad so that you can see it's bad. So most of the time, you're going to write tests and you go, okay, it's all good, everything's fine, great. Now, I'm going to give it a bad input, and I should get a bad output. If you get a good output, then it's bad. So, for example, in your assertion for a specific result to be true, you might swap it to be false, rerun the code, and then it fails. Okay. Or if you're basically if you're in the arrange part, you might change the input to be bad so that you can see if it has a bad result. That basically constitutes as a good test because the test is failing. While having a green test is all great, it looks good, and you have lots of tests come down your screen. You can see you've written 200 tests and they're all green. If they're bad, if you haven't manually failed that test, you don't know if it actually is capable of failing, and that's really important. So, yeah. All right. Let's introduce Pester. So essentially, Pester is just a testing framework. It's included in PowerShell 5.1. It's a module, obviously. It's a module that was included in 5.1. You can go and get it from the gallery. and it basically follows the AAA context. One thing that's really important, if you do have 5.1 and you are running it out of the box, go and update it. Lots of good features that have been added recently. And they're always adding good features. Make sure you always update your PowerShell modules, especially the ones that are out of the box, like in PowerShell 5. So really, really, really important, go update it. So Pester, yeah. So we're going to be using Pester. So, oops. Okay, so essentially, we've got the describe block, the context block, and the it block. I'm going to talk about this. We are then going to go into some demos so you can actually talk what we talk. We're going to actually see what I'm talking about. So essentially, there's three types of blocks that we have. We have a describe block, and essentially what a describe block is it's just a logical group for tests. It basically groups your test groups together. Your context blocks groups tests together, and an it is an individual test. Now, there might be a situation where you only have one test. So you actually don't need to have a context block. You can actually just write your tests in a describe block, because if there's one test, you don't need to actually have multiple test groups, so you can just have a test. The one thing to remember, though, is describe, context, and it are nested in that order. So you have a describe block that's overarching, which basically is all your group test groups. You have a context block, and then you have an it block. You can't have an it block outside of, and vice versa. You can't have a describe block inside an it block. It follows that specific inheritance. All right. I think I've pretty much hit all that. Obviously, the it block follows the AAA pattern, so we don't really need to go any further with that, but let's keep going. We're going to write some tests. So let's actually break out for a sec. And we're going to go and have a look at some demos. So first thing we need to do is we're going to actually have a look at the basic test syntax. So I've got here, let me quickly zoom it in so you guys can see. I'm going to get rid of that off the side so we can have a full screen. I just want to make sure that's readable. Just if I can go full screen, that's readable. Yep, that's good. Sweet. So essentially here we have a basic test syntax. So the first thing it's actually looks like, if we're looking at this test syntax, we're going, well, when I first saw this, I don't know if it's you guys, so I'm just going to go and just go off what I found. I'm looking at this going, what the hell is this? This doesn't look like PowerShell. This is PowerShell. 100% this is PowerShell. This is all PowerShell. The best way to remember, a describe block, context block, and an it block essentially are just functions. So if you think of them as a function that you have just declared, and you basically just have nested functions. That's the way I kind of got it in my head, and it kind of helped. But essentially you have your block, describe block here. So you can see here I've got my describe block, and then I have a string here. And the string here is basically, it talks about my test group. All these names get printed to the screen, and they come out like a really nicely formatted test. You can see all you can see all this. So it's really good. You have now our tests. So you can see here we're testing our test groups group. And we have two test groups here. We've got in our context block, and you can see you can have multiple context blocks within a describe block. And then within here we can see we have our test group 1. And now we have following the AAA method, so we've got our range. So we have a var is equal to 1. We don't actually have an act, which is kind of weird because we haven't actually acted on anything. So let's just skip that. But what we're asserting here is we have an it block. And we're saying test is no, we've got our it block, which is our test, O1, and we're just going to, I don't want you to look at this at the moment. We will cover this soon, but I just want you to understand that the describe context and it block and how that the structure of the test is actually set up. This is a super basic test. Now, you can see that, like we said, that you can nest multiple test groups within the describe block. But let's say you only have one test. So what you can actually do here is we can do the exact same thing. So there's no context block now, and we can just have our single test here. So we've got our range, our act, and our assert, and we just basically have a single test in here, and it's that. So you don't necessarily need to necessarily need to have context blocks. One important note here, and I actually wrote this down because it's very important, is that the scope of the execution remains within the context of the script blocks. So script block variable scoping applies. So you remember how we covered earlier, we covered, okay, we have, let's say a variable here. This variable is accessible within the nesting of the if block, but you cannot change it. Very, very important. So if you want to change it, you're going to have to use your script or global variables. So let's actually now take a look at this. Actually, we can just ignore this function. And we're going to actually run some code. So when we write test here, okay, cool. We're actually now going into it. So essentially I have a function here. We're just going to ignore this. It's just a simple add something function. And we're actually going to now look at how the AAA method works. So essentially here we've got our explanation. So we've got our range block. So we've got our describe block, block here, and we're just calling it a AAA explanation. Within there, we're not having any, it's a single test. We're not doing anything funky. So essentially here, we're not going to have any context block. So we're just going to basically have our range. And within our range block, this is where we set up the test. So you can see here, we have number 1 and number 2. Here's where we set up our file paths, our mocks, all that kind of stuff applies within here. I personally like to have my range blocks set up like this. For me, it just helps me articulate within the actual the context or the describe block how it all kind of hangs together. But it's just really it's each to their own. Really, I just do it this way because I like everything to be nicely laid out. Here we have the act. So you can see here we're calling this function that we just had up here, and we're basically adding it. Now you can see we're capturing the result as the result variable. So that's basically we've now performed the action. We've acted on it. And here now we're asserting our response. So you can see here that the if block, what it's going to do is test a single facet of code. Now you can have multiple if blocks, and we're going to see that. But remember, it's just basically this is what's getting printed to the user. So essentially, when you are actually writing your if block, you basically need to write it. It's got to be as English as possible. So essentially here we have it should equal 3. So essentially you're just writing it as English as possible. It should be 3. That's basically what we're doing. We're basically trying to say it should be 3. Now, within the if block, we're actually now going to do our assertion. We're going to assert. So you can see here we're piping the output to the commandlet should, or the function should. So essentially the should commandlet allows you to test the action, allowing you to do the assertion, or you can do the assert. So I've got a quick little link here we can actually look at, which is really important. And you can see all the functionality that it provides within what you can actually assert. So we can do, we can do negative, so it should be true, it cannot be true, things like that. You can do arrays, you can do there's a lot of stuff we can actually use it with, which is really what its intended use is. So in this instance, we're just going to say should be 3. So we've got our number 1, which is, we've got a number 1 of numeral 1, and we've got a numeral of 2. We should expect that output to be 3. That's what we should have. Now, I'm actually going to run this. I don't know if this is going to work because I don't. Actually, no. We're gonna run through I'm gonna run through it later. Sorry, I'm just kind of like looking at the ones down there. So now we have multiple tests. So what we have here is we're going to do the same thing, but we basically have multiple context blocks. So let's go back to add something. So remember how we had add something, and now we're actually going to have a bit of a look at it. So we have here number 1 and number 2. We're just basically doing a single add. But the thing is, you know what? It actually can add, we're only adding a single instance. It can actually do other things. So there are other ways there are other items that we need to test. We need to test positive numbers. We need to test negative numbers. We need to test positive and negative numbers. And we need to test decimals. So we actually do need to write more tests. So let's go ahead and, so what we've got here is we've got multiple context blocks. So I'm just going to shrink them all. So you can see here, each of those specific tests is a context block. That's all they are. So we've got our previous test, which is the positive numbers test. So that's exactly the same as what we have here. I've just removed all the comments. Note that we're basically just, this time we're not actually arranging it. I just need to quickly. Note that we basically, we're not arranging it. We're just basically acting on it. And we're just passing it directly in there. That's completely fine. There's no issues with that because we know that it's a positive number. We can just pass it straight in, and which should be 3. That's a valid test. So then basically we have a negative test. I'm actually just made a bit of a boo-boo with this, so I'll just quickly fix this. So we have a negative test. So essentially we're doing the exact same thing, except we're just passing a negative number. Note that I'm using the same numbers. I'm not basically trying to overly complicate this. I'm just trying to keep it as basic as possible. It should equal -3. That's basically what it is. So let's go through it again. So we arrange, we're acting, we're basically on the act, we're basically passing the values directly into it. We're using add something. Is that actually, yep, I misspelt it, lol. And then we're passing those negative numbers in. And then what we're doing within the if block is we're basically saying it should equal -3 and we're passing it in. Simple as that. Cool. Now we have positive and negative numbers. So positive numbers, same thing. We're now passing a -1 and a 1, and it should equal 0. That's as simple as that. I'm just going to fix up my boo-boo. Let's do that, like so. And then the final one is decimals. So we're passing 1.5 and 1.5. Again, I'm trying to keep this as simple as possible. 1.5 is a nice round number, no issues there. And it should equal 3. So let's actually now go ahead and run this. So I'm actually going to go ahead and run this test. I want you guys to actually see what it looks like when we run this. So the first thing is, you can see up here, this is what it looks like to have a failing test. So when we had the, if we scroll up, we had, I'm just going to get rid of that. We had up the top, we had test groups group, which is up here. You can see here it's printed out the describe block, it's just printed out the context block, and it's var should equal 2. We know that's a failing test. This is what a failing test looks like. Expected 2, but we got 1. And you can see the following one, that one passed. So we described the AAA explanation that passed. And then we basically, that was using add something. So we're basically just doing the simple add. Here, now we're actually, this is the specific piece of code that we actually are wanting to test, which is, well, we're not looking at them yet. This is the one we're actually wanting to have a look at. So we've got the AAA explanation. So we've got should equal, oh, sorry, no, testing something. So we've got positive numbers. It should equal to 3. That's perfectly fine. We can see that test pass. Then we have negative numbers. That should equal -3. That's pass. That's perfectly fine. And then we have positive and negative numbers here. Should equal to 0. That's passed. We're fine. And then the final one here is we should testing decimal numbers. Should equals 3, but we got 4. It's failed. Something is wrong with our code. We know the test is fine because the test is simple, it's easy, it's concise, it's easy to use. So there is something wrong with our code. So let's go take a look at that code and let's see if we can spot what the issue is. So essentially here we have, we've got our cmdlets, we've got our parameters declared here, they're mandatory, which is fine, and then we're doing an addition. We'll quickly just run our quick tests. We'll just quickly check it. We'll adding 1.5 to 1.5. That should equal 3. There's no doubt about it. Something's not right here. So if we have a look at it, we know that everything's fine there. Well, let's try and work it out. So what we can actually do here is we can drop a breakpoint. So what I'm going to do is I am going to put a breakpoint right here. We're going to rerun our test and we're actually going to have a look at what it's doing. So we know it's 1.5 that's passing in. So let's go ahead and run it. So now we've hit our breakpoint. Let's go and work out what's going on in our code. So we're going to step in using F11, and let's actually inspect. Let's actually add a quick watch on number 1. We need to actually see that. Whoa, okay, that's weird. So you can see it's passed at 1.5, but it's 2. So this function has actually rounded it up. And the reason why is because it's a type integer. It can't be an integer. It needs to be a double. So let's stop our code. Let's clear the screen. And let's change this to a double. And what we're going to do is we're going to deselect our breakpoints and we're going to rerun that test. And what I'm going to do, I'm just going to comment this bottom one out for the time being, and we're going to rerun this code. So now we've rerun our code, you can see now context decimal numbers has passed. So that's essentially a really, really cool basic demo of how we fixed our code when our test found there was a bug in the code. So we needed to accept doubles instead of integers. So that's a really, really cool little demo for you guys. So now let's keep going on back to our code. If I can actually minimize, cool. So essentially we're going to minimize that. I wish I could actually minimize this because you can only maximize it, looks like. Yeah, you can only maximize it. I'm just going to do that. So essentially, like I said, we basically, PowerShell was rounding up to 2 rather than keeping it at 1.5. So that concludes this demo for the syntax and a basic test. So now, if you wanted to actually run a Pester script, what we actually use is we use invoke Pester. So if you're inside a build pipeline, you're actually wanting to run your Pester test itself, you can actually basically use invoke Pester and pass it the script file name, and then basically it will then run it. So let's go ahead and do that. So what we're going to actually do is I'm just going to run this by F8ing it because I don't want to run the whole thing. So I'm going to clear the screen and then we're going to F8. Sorry, I'm just going to do it this way. So you can see here, when we run it, you get your nice little Pester ASCII art, and you can see it's executing all the tests. And it'll just go through and run the test. This commandlet, you can output the tests into an XML file. I'm pretty sure you can do a HTML file as well. It's very, very versatile. But it'll basically, this is what you will use to actually run your tests within a build pipeline. Now, locally, you can just F5 your script and it'll run it. There are issues that you need to deal with. Sorry, you need to deal with, for example, you need to be able to articulate the folder structure. So if you're dealing with multiple mocks and you're importing mocks from different folders and things like that, that's actually something you need to deal with. But essentially, this is how you do it. So you use invoke Pester. One other thing which is really important is when you're actually writing your tests, you actually use the tests, the .tests.ps1 or .test.ps1 file name. So essentially, that helps. That basically kind of articulates what that helps segment what test is, what constitutes as a test, what constitutes as your script. Most people put their tests inside a test directory as well, so that's also very handy. Alrighty, let's talk about mocking. So here we have mocks. So this is basically, we're going to have a quick look at the URL. I'm just going to paste these into the chat as well so you guys can have a look at them. So mocking. So essentially, you're just mocking, like we said, you're just mocking the behavior. Mocking basically has a whole bunch of different parameters. Sorry, one moment. All right, so mocking basically has a whole bunch of different components to it. So we can see here you can have parameter filters and things like that. We're not going to focus on that. All we're going to be focusing on is basically the basic fundamentals of mock. So we've got a bit of a demo here which I've wrote, which essentially is a mock. So we have our range. So we've got our range and our active assert. We've got our test groups, troop group, and basically it's the exact same syntax test that we had earlier in the first demo. And what we have here is we have a mock for just var equals 1, and basically we're going to mock the command name right host, and we're going to return 1. Now mock, when you use the mock with parameter, so essentially when you use the mock with, you're actually returning code to the you're actually returning an output. Essentially it's a TypeScript block, so essentially you need to just nest it in within a script block and then return 1. Now one of the things that's really important here is you can see that you've got the command name. This only works for commandlets. Now you can mock modules and things like that, but this only applies to commandlets. It doesn't work for methods, it doesn't work for objects. That's something that's really important. And then you have the mock with, like we said, it's a script block. Just think script block. You're basically returning the behavior. Now, if you don't want to mock anything, you can actually just mock it and exclude it with, you can actually exclude the mock with, and we can do this. So I could actually just comment that out and I could mock right host like that, and it would print nothing. So, but in this instance, we would just do that. Now, right host doesn't apply here, so we're just going to move on. This is just more for demo purposes, but essentially that's how a mock is written within your code. So now this is actually a proper mock. Let's actually do something with some mock. Sorry. All right. So here we have the same function. Just need to quickly check, make sure that I am still good. Yep, sweet. Here we have the same function we had, add something. But instead what we've done, I've replaced the parameters to a CSV path, and we're importing a CSV. This is something we can mock. And then what we're basically, we're doing addition on the two properties, number 1 and number 2. Not the best way to do it, but nevertheless, we're doing it that way. So let's, we've already reviewed the function. Okay, so there's actually one thing I've just missed, which is actually something, the reason why I wrote the note. So essentially, there are two things we actually need to mock here. We need to mock import CSV, and we need to mock test path. If we don't mock test path, it will fail. And the reason why is because if you pass it a mock, if we pass test, it will legitimately do a test path for test, and it will fail. And we'll have a terminating error. So we need to actually mock test path as well. So let's just focus on the positive numbers test. We're not going to be focusing on all the other tests. We're just going to be focusing on that. So let's mock test path. So test path is a Boolean commandlet. It returns true or false. In this instance, we want it to return true. We don't care about whether it's true or false. What we care about is it. We need to actually get past that specific commandlet so we can actually perform our action. So we're just going to mock it to say test path is true. And then we're going to mock import CSV here. So what I've done is we're mocking it with this, and I've basically just got a custom object that's going to write output. And then basically it's just doing a number 1, number 2. Not the best way to do it, but for this demo, it's fine. Now, if you wanted to do a large file, this is something that what you would do. You basically import your CSV, you mock your CSV, and then you would just use import CLI.xml or import CSV, and you would just present actually it's in CSV. You would import CSV to your mock CSV file, and that is how that would work. So essentially, please don't tell me I just did something bad. I think we just closed it. That's how that would. That's a quick, nice little demo for you guys to knowing how to do that. It just applies to test or any sort of test production data. And it's really handy because it means that you don't you can actually take that data offline and then work with it, and you don't actually have to go and continually go poll production. You can just use that test data. It makes it so much easier, and it's so much faster to test with. So here we're passing a phony string into the file. We do not care about the path. What we care about is the content of the result. So what we're going to do is pass test. It's nice, and that's very simple. People then understand that we don't care about the test, or we don't care about the file path. And then it should equal 3. And so we're running 1 + 1 and +2. So let's go ahead and run this. And you can see we're forgetting the first one because that's going to naturally fail. But you can see here, describing testing as something. Context boxes and numbers should equal 3. So there you go. That's pretty much that. But I want to quickly show you guys how the mock works. So what I'm going to quickly do is we're going to actually drop a breakpoint here. And then I'm going to rerun this again. And you can see now we've hit the breakpoint. So let's go ahead and step in. And we're validating our script. So we're going into test path. So you can see now we're actually now on the test path and within our script validation. And you've known we're now, if I can scroll up, we're actually, I'll just see if I can move this. We're now inside the script listing. So essentially what's happened now is Pester's actually taken that test path and now is actually starting the mock process. So it's now going, okay, I want to execute that script block that we had, and that's what's actually going to get passed back to the caller. So essentially now, I'm just going to step over. Test path is true. So if we actually drop another breakpoint down on line 58 here, you can see if we actually add a watch for CSV. Oops, that is not that. It's CSV. You can see here it's returned our PowerShell object, and we can see number 1 and number 2, and then it's going to add it and return to the caller. And that is basically how mock works. It's really quite simple. It's just proxy functions. So that is concludes our second demo for mocks. So if you've got questions, like I said, throw them in chat and I'll be happy to answer them. So I'm just going to remove all breakpoints. What do we have now? All right. We're now going to write a basic unit test. We're going to look at some basic unit tests. So I've wrote some here. I do have some scenarios, so I will actually be writing some unit tests. But I'm kind of looking at time, and I do think that we might be having a part 2 next week, because I do think we're going to run out of time. So let's write a basic unit test. So what we've got here is a basic function to multiply something. So you can see here we've got our parameters set up. We've got basically these, the first 2 are mandatory, and then the second one is not mandatory. The third one's not mandatory. We have 3 numbers. Within here, we basically go, okay, if it's number 3, multiply all 3 together. If it's number 2, then multiply the first and the second parameters. Now, we're going to give our describe block something meaningful. So I usually just go testing, multiply something. I'm going to give it something that basically is easy to understand. Because remember, actually I could have just done this. Hang on, I'm going to put that back down and I can just do this. Remember, when you're specifying, it gets printed to the screen. So you just want it to be something meaningful. That's fine. Now we're going to describe the code execution paths. Because remember, there's actually a few types. There's 2 types of code execution paths we have here. We have the number 1, number 2, number 3, and then we just have number 1 and number 2. Because we have 2 mandatory parameters, and then we have 1 optional parameter. If the optional parameter is specified, it will multiply all 3. If it's not, it then is excluded. So here what we can do is we have 2 tests. So let's describe our first test, which is number 1 and number 2. We're just going to multiply the 2 mandatory together. So let's arrange it. We don't really have anything to arrange, so we're just going to move over to the act. we're going to call our function, multiply something, and we're going to pass them the two actual, the two values, which is 1 and 2. And then we're going to assert. It should equal 2. This value should equal 2. We have now we have number 1, number 2, and number 3. So let's actually look at those ones. So we're basically, again, we're just calling now the number 3 parameter. That should actually equal 4, because 1 times 2 times 2 is going to be 4, because 1 times 2 is 2, 2 times 2 is 4. So, yeah. All right. So what we're going to do now, I'm just kind of, we'll talk about writing a good test later, but we're gonna write a failing. We're gonna fail our test later. I'm just reading through my notes. We're gonna fail our test later, so we're not gonna do that. But essentially, let's go ahead and run this. So you can see here, I forget all that. That's just me in the previous run. You can see here we're multiplying something. Forget this bottom one. But essentially here we've got number 1 and number 2 parameters. Should equal 2, that's a pass. Number 1, number 2, number 3 parameters should equal 4. So when you're reading this, you can understand, hey, it's easy to read, it's easy to understand, it's simple. The test is easy, very, very easy to read, it's very easy to understand. All right, let's actually do something a little bit more complicated. So we're actually going to do read choice. So this is a function that I wrote that I'm working on a current module for. And I actually wrote some unit tests for this. And as you can see, this is actually quite a comprehensive test. There's a lot going on in here. So you can see here we've got some mandatory parameters, which is the message and the expected result. We have a help message, we have a default value, and we have a retry count limit. So if there's a default value, we're going to append that to the message. If there's a help message, we're going to append that. We've got a retry count to 0, that's fine. We're prompting the user for some input with the message. And then basically we're prompting, if the prompt has a exclamation mark and question mark, we're going to print the help message. If it doesn't, and if it has a, if it's empty, we're then going to set the default value. And then we're just going to increment it. We're going to add to the increment counter. And basically we're saying if the prompt is within the expected result, so if there's the expected results correct, then exit. Or if the retry counter is at the limit, which is 10, we're going to exit. And if it hits the limit, we're going to actually throw a terminating error. So that's basically this function. It's a little bit more complicated, but this is a really, really good example for mocking and different code execution paths. G'day, mate. How's it going? Thank you for stopping by. So within here, we have multiple code execution paths. So we have a standard execution with mandatory parameters. So we have our standard input, which is message and expected result. We have that including the help message and the default value. And we actually have one more, which is a invalid response. There's actually a fourth, which is an invalid response. Oh, nice. It's always good when you actually wanted to come and watch the tests. So just to give you a bit of a recap, we've covered all the fundamentals. So you're pretty much going to need to, I don't know if you've been watching it from your mobile or anything like that. But at the end of the day, though, it's all on YouTube. So you can pretty much just watch where you just before where you jumped on. So we've been going for about an hour now. So yeah, but essentially, yeah. So we've got a fair bit of code execution going on here. But we actually want to test this code execution path out. So what we've got here is we're going to use the Assert Mock called commandlet. Basically what this commandlet does is it allows us to validate a mock on whether it was called or not. So we can validate, hey, was this called? Was this called? If it was, fantastic. If it wasn't, we have a problem. So it's really, really good because it allows you to actually make sure that your code is actually going into the correct execution path. So here we're actually going to now write our test. So again, we're going to give it a meaningful name. We've given it standard execution. Actually, I think, yeah, and actually I haven't actually tested that, so we're actually going to remove that. So we're going to test our standard execution. So we're now mocking write host. We're not interested in anything there. We don't really care if it gets printed out. We don't really want it to be printed to the screen. It's going to make it look ugly. So what we're going to do here is we're just basically just going to mock it and have no output. And then we're going to mock read host. And this is actually one of the harder things to mock because we'll talk about this later in terms of how to actually write testable code. But essentially, when you're mocking read host and you have it inside a loop, you need to be able to make sure that that test code connects to the loop, because if it doesn't, your code will just sit there and infinitely loop. So we don't want that. So what we're going to do here is we're going to mock it with return test. Again, I'm trying to keep the code as simple as I possibly can. It needs to be maintainable and simple. We're not going to be using any sort of fancy inputs. We're just using tests. Now we're going to invoke the command. So you can see here, we're going to just call read choice. The message is test. The expected output is test. The result is test. And we know that it's going to succeed because we're passing it a return of test. Everything should work. The word is should. And that's where we assert. So we're asserting that basically it should return test. That's our first assert. Like I said before, you can have multiple its blocks. So you can have multiple tests that you're testing for. So here, it shouldn't have called, should not have called write output. That sounds so, I'm just going to say shouldn't have. I can't spell shouldn't have. Shouldn't. I can't spell shouldn't. I literally am having a memory blank. I'm literally going to have to go to Google right now. Jeez. Oh, that's right. Okay. I literally looked at that and gone, that didn't look right. So it shouldn't have called write host. We want to make sure that it didn't go in here. So we're actually making sure we're testing for the code execution path, not within here. So let's keep going. Let's keep going having a look. So shouldn't have maybe instead of shouldn't of. Yeah, it's really, yeah, you're right. Yeah, shouldn't called right. Shouldn't called write host. Essentially it needs to be English, so I'm just going to say should not call write host. I'm just going to say that because I can't English today. All right, so essentially it shouldn't have called that. The second thing that we need to test is with the help message. So we're going to pass the help message in here. Now, one of the things with this specific piece of code is that it's going to just continue looping, prompting for the help message. So we know that after 10 times, it will fail out. So what we need to actually do here is we're going to need to write our code a little differently to be able to handle that. So what we're going to do here is we're actually going, note that we're actually using, we're acting within the assert, which is kind of weird. But this is the way how we actually need to do it within Pester. So essentially what we need to do here is we then pass it the script block of the act, and we're basically saying it should have thrown this. We should have got a terminating error that said this. And it should have called write host. We should have seen the output of, we should have seen, where are the messages? We should have seen this code line, this line of code get executed. That's the key part. So that, and what we see here is when we're using a Assert Mock called, instead of using, and I'll just quickly scroll up because that's one thing I kind of went over. We're using the exactly parameter. We exactly want to, should be 0 times. It should never be more than once. Here, it's going to get called more than once. So we just care about it should be called more than once. If it has, it's fine. We know that it's working. So that's completely fine. The final one is we're actually testing standard execution. So essentially here, you have standard execution. So, and with the default value. So this is the same, pretty much the same test with the help message, except we don't, we're just passing it a default value. So the default value part is if you pass it a blank value, it should just replace the blank value with the default value. So here, we're going to mock write host. We're going to mock read host with absolutely nothing. We're going to actually physically pass it an empty string because that's what read host is expecting. And then we're going to invoke the command. And so you can see here again, we're just passing it a basic command, expected result test, default value test. We expect the read host empty string value to be replaced with test. That's what we expect. And we assert that, so we say should return test, should be test. Since we didn't specify a help message, we can also assert that write host shouldn't have been called. So we're going to use assert mock called, command name write host exactly 0. It did not get called. That's really, really important. We do not want it to be called. All right, so that's test. Let's go ahead and run it. So you can see here, all our tests passed. Fantastic. We know our code's good. Somewhat. We haven't actually broken it yet. That's one thing we're going to talk about in another demo. But essentially, this is how we write a basic test. This is essentially writing a basic unit test. All right, now we're going to write a basic integration test. So remember, the difference between a unit test and an integration test really is unit test basically interacts with itself and uses mocked data. An integration test is actually using externally accessible values. So you're actually not really mocking. You're using a test SQL server. You're using an actual connection, an externally accessible or an externally accessible item from your test. So let's do it with add stuff. So here we have a basic integration test. So essentially, it's going to write to a file. Essentially, we're just going to, I've called it add stuff, which is really bad because it's not really add stuff. No worries, mate. No worries. I think it's really important, and I'm going to just write stuff. I'm just going to call it write stuff because really that's really what it's doing. It's not add stuff. So I'm just going to kind of refactor it. I'll just change this. I'm literally rewriting my code in a demo. This is like the worst thing you can do. So we got write stuff. So you can see here we've got a file path, we've got some context block, and we're going to out the file. Cool. Sweet. We're good to go. So we're going to write. We're going to basically have our describe block. It's a meaningful thing. Now, one of the things I wanted to actually note here is note the tag. Actually, I think that's actually something I didn't actually do in this other one. Did I? No, I didn't. So within the describe block, you can tag your tests. Tagging your test is really, really good because what it means is that you can actually, when you invoke Pester, you can just invoke it and say, I want you to basically run all the tests with the tag integration, all the tests with the tag unit. And you can then just go, and so you can tag your unit integration tests, and you can then just run them as you need them. So tagging is really, really handy. And you're going to see this a lot more in our further tests. It's just a little thing that I've just added in. So we have a single test group here, so we don't need a context block. So we're just going to write it all inside a describe block. Now, one of the things you can actually note here is that we have a problem, which is how do we write to a file without actually having to maintain the state? I don't want to have to clean up the file. I don't think if you're running this in a build pipeline or anything like that, you don't want to have to run cleanup on it. You just want it to work. So one of the things that Pester has is this feature called test drive. I'm just going to paste this in the chat. Essentially what test drive is it's an emulated drive. It's basically you can write files to it. It's completely emulated and it's within the scope of the test. Very, very handy. So essentially, it uses the test drive as a drive letter, essentially. And so what we can do here, we can use this to actually write our file, physically write our file. So here, let's actually give our test a meaningful meaning, which we've done. And our path for our test, we're going to do it within our range, is going to be test drive. And we're going to give it test.txt. In our test, we're going to actually write some stuff. So we're just going to basically go write stuff. We're going to give it a path, and we're going to write the context of test. And then we're going to read the file to make sure what we wrote was fine. It should contain test. So when we read the file, it should contain test. And what we're doing here is I'm just doing a quick join just to make sure that if there's multi-lines there, we're not getting any sort of shenanigans there. So essentially, let's go ahead and run this test. And you can see that's passed. Perfect. And this is the really cool thing I love about Pester is the fact that we can do this. We can emulate drives and things like that. We're not constrained in having to write code to manage it. We're just basically writing simple code and that's it. We're focusing, it makes our tests much more easier to understand than if we basically write all these large swaths of cleanup scripts and things like that. So we're now going to have, I'm just quickly having a look, like I'm trying to be aware of time. I do think this is going to be a part 2 because there's a lot of tests. So let's write a good test. So we're going to use the same tests that we did before with multiply something, and we're going to actually write the principles of writing a good test here. So remember, we had 2 execution paths for multiply something. So like we said before, we had the first one, the second one. The whole principle applies, like I said before. We're going to arrange our code to make it neat. It's concise. It's easy to read. The one thing that we do need to do, though, is we need to fail our tests. That's the key thing. We need to fail our tests manually to make sure that it is working. So I'm just going to drop a pause here. Actually, no, first thing we're going to do is we're going to run this test. Let's go ahead and I'm just going to terminate this PowerShell and we're going to restart it. And we're going to just run it and we're going to pause and then we're going to stop it. And then I'm going to Control C to stop it. And you can see our test run. It runs perfectly fine. But this isn't a good test yet because we haven't validated that it's a good test. So what we need to do here is we actually need to manually fail our test to make sure it's a good test. So let's go ahead and do that. I just lost my, oh, there it is. I'm just going to leave it there. So what we can do here is let's change our values. Let's change this to, let's just change this to 3 and let's change this to 3. And let's go ahead and rerun our tests. And you can see here, both tests failed. That is now a good test because we failed it when we placed an invalid value in it. We know the test is working correctly. And this is really important. When you're writing a test, fail your test because then you know that it's working and yeah, it's working. So essentially, we're just going to undo that. We're going to that is basically a thing. Now another thing you can see here is I've tagged it with the unit. So I'm using the tag parameter again. I'm tagging it as a unit test. So when I go and run this in my build pipeline, it's tagged unit. It's super easy. It's super concise. It's very, very easy to understand. There's no issues with that test. All right. Let's actually go ahead and look at read choice again. So read choice is quite a substantial function, and we actually need to now write some extra tests. So in the previous demo, we actually went through 3 code execution paths. In this demo, we're actually going to have, there's a 4th execution path that I didn't test because it's something that we do need to test. And the 4th execution path is the failing test with an invalid input. We never tested what would happen if they didn't put an input in that wasn't what the expected result parameter value was expecting. So that was something else that we didn't do. And there's actually a few other items that we need to do here. So you can see here, we've actually we've got a whole bunch of different tests now that we actually need to go through and look at. So I'm just going to minimize this and we're going to go through. So again, we've tagged it unit, and I've got this extra one. I've got this extra unit tag on it. Tags can have multiple. You can have as many tags on it as you want. So I'm going to I've tagged it with choice. So essentially, this, if I want to run the choice element, I can just run that. So it allows you to target a specific aspect of code, or a subset of code. So now we're mocking the read host. We're basically testing our standard execution. Nothing's changed here. The one thing we do need to do is we need to fail this test. So you know what we're going to do? We're going to fail it. So we're going to rerun all our code. I'm just going to remove that pause if it haven't already. Yep, I have. Sweet. So we're going to run this code. I'm just going to restart PowerShell so we can get a clear screen. And we're going to run it. Let's go ahead. So you can see here all our test paths. Like I said, it doesn't mean anything until we've actually failed our test. So let's actually go ahead and do that now. So here in our first execution path, we need to fail this. So where do we need to fail it? Well, we can actually fail it in our mock. We can fail it here. We can fail it in the expected result. There's a lot of places we can fail it. But essentially, the easiest place to fail our test right now is our mock. It should return test, and it didn't. So what we're going to do here is we're going to return fail test. So when it prompts for read host, it's going to return this. So that's the first thing we're going to do with this one. So let's go ahead and run it. And you can see here, now we have another type of error. This is a terminating error within the context block. You can see here we've got our terminating error get printed out to the screen, and the context block doesn't say should be this, should be that. It's a terminating error. Something went wrong in the context block. This means that something is not right with this test, or not with the test, but with the code. So we know that that code is working correctly. You've motivated me to sign up for a few tech meetups. Oh, nice. Yeah, it's really good. I found that running a PowerShell user group is one of the things that, like, it really, if you want to get good at PowerShell or you want to get good at something, then go to a user group, because you're just constantly learning different things from different people. And that's the biggest thing, is that in your role, you won't do that. So you'll be doing the same thing. And because you're doing the same thing, you're not doing what someone else is doing. And so it's just really good to see what other people are doing, and then you can actually decide whether you want to implement that or not. All right, so let's take tests. But yeah, man, I'm stoked that you're going into a user group. That's awesome, man. It's really, really good, and it's going to push you. It's going to, like, if you really want to, like, pursue PowerShell, it's going to push you so far. Like, user groups are just fantastic for that. Yeah. Like, I found that, like, streaming, like doing PowerShell 101 live, like that, my PowerShell's like, because it forces me to do extensive research into everything to make sure that I fully understand it before I can present it. And then the second thing is that then running a user group, you can actually see the other aspects. And like you said, you got GitHub, and you can go say, hey, I want to do this. And being a contributor and getting really active in the community is really good, because it means that then you can, you can interact, and you're actually contributing to people's modules, and it really helps. It helps you from a personal development level. So, yeah. Anyway, so we got standard execution with a help message. So what happens if we throw this? So we can actually, so we need to fail this test. This test is concisely written. It's very easy to understand. It's really well maintained. So what we're going to do here is we're just going to basically fail. Instead of returning $? We're just going to fail. We're just going to return test. And this, we want to see this fail. So let's go ahead and restart PowerShell. And then we're going to go ahead and execute this code. And we're going to bring this up. And let's go see. So we got testing standard execution with help message. Okay, we still got an error with that. Yes, that's exactly right. It should have, okay, so what we should have seen here is it should have thrown a terminating error. That's what we were expecting. Fantastic, that's good. And it should have called right host, and it didn't. So that code execution path that we're talking about didn't get entered, therefore we have a problem. So this is one of those really important things why we fail our tests. So we know this test now is good. So let's just replace that back. We know this test is good. And now we have testing standard execution with default value. Again, let's pass it. This is actually going to be a hard one to test because essentially we can't test that code execution. This is something that I should have actually fixed. So essentially here, you can see here, I'm testing for the default value. And I could pass it something else, but this test is not, well, I won't say the test is not bad, but the code is bad. I actually need to refactor this specific piece of code so that we can actually test this specific code execution path itself as well. And that's something that I didn't actually think about. So this is actually not a good test at the moment, and this is something that we're going to need to work out. So what I could probably do is what it said is I could we could change the assertion to see if it fails, but I don't think that's actually going to be a proper failure. So we'll skip this one because that is actually not a really good one to use. The final one, which we didn't do in a previous demo, was testing an invalid input. What happens if some guy basically sends something that's not supposed to go in there? So if basically passing in the invalid, and then basically I've reduced the retry count limit as well, just to make things a little quicker. We don't want to loop 10 times. If it can loop 3 times, it's fine. And we're expecting it should throw this specific error. That's what we expect. So how are we going to test that? So we can actually just validate it by actually passing it in a correct value. So let's pass in the correct value. Let's restart PowerShell, and we should get an error because it should have thrown a terminating error, and it didn't. So let's run that. And you can see here, it should have thrown a terminating error, but it didn't. So we know that this test is not good. Oh, sorry. This test is good because if we rerun this test again, we get that terminating error. So that's actually how we write a good test. We basically make sure we arrange it. It's nicely formatted. It's easy to understand. It's easy to use English. You're basically trying to write, this is all trying to be as close to English as possible, so that basically it's just, yep, okay, I know what the issue is. And you don't want to spend much time in here. You want to minimize the amount of time in this. So you want to make it as easy for the person to read as possible. So look at that. That's done. Cool. So that is basically a good test. Let's talk about code coverage. So let's write some tests. Let's pass the code coverage. And then I was like, oh, okay, I did actually have something here. So let's talk about code coverage. So essentially, code coverage is the ability to be able to actually measure the amount of execution or and the amount of tests that you have written for your code. So essentially, it's a really good way to be able to, if you've got a large project and you run code coverage against it, and your code coverage is 20%, you're going to need to write more tests because the code coverage has found multiple execution paths that you need to actually test on that you haven't actually done that. Code coverage is really easy to use with Pester, so we're actually going to see a demo of that. And as a rule of thumb, it's usually about 70%. Now, there is nothing wrong than writing over 100% code coverage. You can write minimum 70 and then be happy. But if you want to go the extra mile and you want to test for every facet and you are meticulous with your testing, go right ahead. It just means that a lot more people will come to respect your tests because at the end of the day, you're taking that effort to test it. So code coverage is not a big thing. It's more the quality of the test, but at the same time, though, code coverage is still quite important to make sure that you're writing enough tests that basically you're testing all the aspects of code. That's basically code coverage. So let's go ahead and look at some code coverage. So we've got I've got a code coverage here. So essentially, the way that you do it is you basically use invoke Pester, you specify the code coverage parameter, and then you specify the script. So let's go ahead and run this. And you can see here, it gives you a whole bunch of information. Now it says 0%, which is, I think I've done something wrong here. But essentially, it'll tell you what you need to actually test. Now, this is weird because it looks like it's actually running code coverage over my test. When it should be running the test. So yeah, there you go. So it's running. So for some reason, it's running the. It's not running the test. It's just running the code coverage on the test. So obviously that's going to fail. But essentially, it's really cool because you can actually see. Okay, yeah, I'm at 80%. I'm at 90%. I'm at 100%, and you can actually validate that. So that is pretty much code coverage. So what we're going to do now is we've got some scenarios. So we've got some scenarios here. We're going to write some basic tests, and we're going to have an invoke web request as well. I'm just kind of looking at the time as well. What we might do is I'm going to have a quick intermission for 5 minutes, so you guys can stand up, grab some water, have a quick stretch your legs. We'll have a quick 5-minute break and then we'll come back and we'll write one of the scenarios. I think we are definitely going to need to come back to this next week and we're going to need to focus on the other parts next week. And then I might tie in logging and that will finish 101. So let's have a quick intermission and stand up, stretch your legs, and we'll be back in, let's say, we'll say 10:44. So yeah, all right, we'll be back in 5 minutes. All right, we're back. We are back. So today, so let's get cracking into the scenarios. We're probably just going to do the first scenario, and then we're actually going to finish up the stream for today. So let's jump into our scenario. Let me just focus on the screen. And yeah, so what we're going to be doing here is we're going to be writing some unit tests for divide something. So we've got two execution paths, really. We've got the first execution path, which is, I just want to make sure I'm not, yep, I'm good. Sweet. The first execution path is 0 divided by 0, which is going to return a terminating error. And the second path will be returning a value. Will the continuation of it be next year, next Friday? Yes, it will be. This will be the yeah. So I will be streaming next week, and I'll probably be sticking on logging on the back side of it, and that will conclude PowerShell 101 live. So I'll conclude that segment, and then basically we will start. I then have to write my PowerShell Summit talk, so that's my next thing I need to do. So I'll be using the time to do that, and then from once I've completed Summit next year, because I am presenting at Summit next year, I will be doing PowerShell 102, which will be covering more advanced content. So that will be basically when we will pick it back up, and we'll be basically going into other aspects. So yeah, so I don't know if you're aware as well, but Summit has like 100 tickets left. It's literally, I don't know if it's been sold out or not. It's so close to being sold out now. So this year's Summit is really, there's a lot of speakers. Let's see if I can bring it up quickly. Summit 2020. It's in Bellevue, Seattle. Oh my gosh, it's on Twitter. Yeah, less than 100 tickets left. So apparently it's just been absolutely exploded this year, which is really cool. So I'm actually presenting. I'm giving a talk on Summit, so I'm actually really excited that I've been accepted. So I'll be flying over to give a talk. But yeah, definitely worth checking out. I'll just chat that into the link. So that's in Bellevue, Washington, / Seattle. So yeah. Anyway, so let's get back into writing this test. So we've got determine our code execution paths, and we need to return some values. So the first thing we need to do is actually write the function. So let's go ahead and do that. So you can do different types of approaches. We can do test-driven development, things like that. But for the sake of just for everyone, I don't particularly want to expose TDD to. No, it is. Anything specific that you'll be speaking about, or is that to be there? There is a speaker schedule. Let me just quickly bring up. I'm just going to quickly hide my screen for a sec, and I will just quickly grab the schedule. I know there's a schedule online that people can look at. Focus me, no screen. Speaker update. So this is this is who's actually there. So we have. I wonder if they've updated me. No, they still haven't updated me. I've got a nice photo on a bio, but they haven't added me yet. So there's a whole bunch of different things. So mine is I've actually also had like they've got to clean it up as well. But essentially, I'm actually talking about the components of how to actually automate correctly in an IT environment, building on correct IT best practices, and then actually automating. So that's my talk, which is talking about identify, simplify, and automate the 3 tenets of creating a serverless IT self-service portal. So basically, I'll be building a self-service portal using various technologies. So it's very, but yeah, there's a lot, obviously there's a lot in there. So I'm actually very excited to go. And I'm kind of glad I'm on a Wednesday, which is kind of midway through. And then I'm also I'm at 9 o'clock in the morning, which is not too bad. It's a pretty nice, that's a good time to have it. So anyway, so first thing we need to do is write our code execution path. So we're just going to go divisible by 0. So we're just going to say if number 1 is equal to 0, or actually I'm not even going to do it like that. That's just too much effort. I'm going to do it this way. I'm going to say number 1 and number 2 contains 0. That's a super lazy way of doing it, but that should be fine. And then basically we're going to throw a terminating error. And we're going to say here, then we're also going to then do our return. So we're going to basically just go return number 1 divided by number 2, like so. Cool. So we got that. Yeah, definitely check it out, mate. Even if you can't go, the videos are going to go up online, and there's a lot of really good content there. A lot of the guys, I can definitely send you an invite. I know that there's an invite floating around somewhere into the Slack. I'd say the Discord the official PowerShell Discord. And you basically, yeah, you can. It's really good. Like you can pretty much chat to. We had a the guy that one of the guys that actually really maintains the desired state configuration in PowerShell. We actually were giving a PowerShell channel. We were giving a PowerShell talk, and then one of the guys I know, one of my mates, he actually invited Gail, who's the guy that Gail into our live stream, and all I remember was one of the guy who was moderating chat just say, Wayne, he's like, yeah, Gal's in channel. He's like, oh, ooh, you got, yeah. And so you have a lot of the big guys in there, which is really good because it means that you can go and just ask them if you have a specific question. So, yeah. All right, so let's go ahead and write our tests. So what we got here is so we've got our function, which is divide something. So let's go ahead and write our test. So what we're going to do is use our describe block. We're going to give it a name. So we're going to give it something. We're just going to go testing. We're going to call it divide something. And we're going to give it a tag of unit and math, like so. Open our curly brace, and we're going to get stuck into it. So next thing we're going to do is we have 2 tests. So we have 2 test groups. So we're going to have context. And we're just going to have our first execution path, which is number divisible by 0. And our second one will be standard execution, like so. So what we're going to do here is I'm going to put my nice layout because it just helps me. So we can put the AAA in there. Sweet. So once we've done that, we can now basically start to arrange our tests. So what we're going to do now is let's arrange our tests. Do what we need to? Oh no, we don't actually need to put anything there. So we can actually just pass the values directly into this. So we're going to go okay. So it's going to be producing a terminating error. I'm just looking at this. Let's write the first one. Let's write standard execution. So we're just going to write the result, and we're just going to go divide something. So we're going to call I'm going to number 1, and we're just going to go 4. I'm going to number 2. I'm going to go 2. So we're going to divide by 2. We're going to literally get half. And we're going to assert. So what we're going to assert here is it should equal 2. And then we can basically go result should be 2, like so. So we've written that first test. Now we need to look at the second test. Because it's throwing a terminating error, we don't actually put it inside the act. So we're actually going to have to do our act inside our assert. So what we're going to do is go, it should throw a terminating error, like so. And then in here, we're going to actually then go script block. We're going to go divide something, and we're just going to give it a number of 0, like so. Yep. And so basically that should throw a terminating error, and then we should go should throw, and then we're actually going to give it the terminating error. We don't necessarily need to. I just like to be explicit. I don't know if it's good. And that's it. So now we've got our function. So their function would be in a separate piece of code, but essentially here would be in a separate file. But essentially here we've just got them nested together for this scenario. So let's go ahead and I'm just going to restart PowerShell, and we're going to go ahead and rerun our tests. The first thing we do, we just want to see our test pass. Second thing we need to do, then we're going to need to fail our tests. So let's go ahead and run our code. Fantastic, our code's running. Does that mean it's a good test yet? No, it doesn't. Why? Because we need to fail it firstly. So how we're going to do that? Let's actually put this to be 5. Actually, no, let's change it to 10. Something that we know explicitly that it's not, let's change this to be 1. So that basically we know that it's this will fail. So let's go ahead and rerun our code. And you can see here we have a terminating error. So we have a failure because it should have thrown a terminating error, expected an exception, but it didn't. So that's good. The second thing is it should have equaled 2, but we got 5. Okay, good. We know our tests are working. Yeah, tickets aren't cheap, mate, unfortunately. It's usually one of those things that you kind of have to push to work. And you kind of have to get work to kind of send you on training. So it depends on how work kind of really sees if there's an actual benefit there. So yeah. So essentially we have our passing test. So if we rerun that, oh, we got 2. Got 2.5. Oh, that's because I've put the wrong number there. So we're going to rerun that, and we've got our passing test. So that is essentially our first scenario. We're going to leave it there for today because I think we're definitely going to run out of time. We've got 3 minutes left of the stream. So I think what we can do is we'll leave it there for today. If you guys have questions, definitely start throwing them in. Bloody Valley, I think what you can do, mate, is if you go into just go to YouTube. This is literally simulcasting to YouTube right now. So I'm going to tag it. I'll have to re-tag it because it's going to have to be A. And you can then just rewatch up to where you started, and that will pretty much get you going. So yeah. So guys, I think that's going to leave it there for today. I hope you guys enjoyed it. I was definitely running short because obviously we there's a lot of content to go through. We've still got a lot more to go through. We've got a few more demos. We've got parameterized tests. So there's a lot more stuff to cover out of this lesson. So we're going, yeah. So if you've got questions, leave them on, throw them up on Twitter, throw them up wherever, YouTube comments, whatever. If you like this course, because we're really coming to this course is kind of coming to an end, don't be afraid. Send it to your mates. Send it to your colleagues at work. If it's definitely helped you, send it to them. Because at the end of the day, though, it's free. You can't beat free. Ultimately, you know, it's exactly it's the best thing in the world. So if you basically, yeah, if you really like it, yeah, and just promote it. because it's really, really good for obviously helping the community and obviously getting people to understand PowerShell. I do definitely think that there is a skill deficit within the area, and people are very hesitant to use it to script, to do anything like that. They'll generally use one-liners and then kind of go, oh, we can do something over here. Or if they do write it, they're not writing it in a way that can potentially be fully leveraged. So they're writing very basic scripts and they're kind of, those kinds of things. So this is going to teach you the fundamentals. It's going to get you up and running, get your mind in the correct position to be able to actually smash PowerShell and do it well. So anyway, guys, I hope you liked it. Thumbs up, all that kind of stuff. If you're watching on YouTube, subscribe on Twitch if you love it. And then, if you guys want to obviously have suggestions for the next one, that's going to be happening probably after April next year, because obviously I need to write a talk. Do it, just flick it on Twitter, same thing, comments, YouTube, that kind of thing. But we'll be back for guys in America Friday, for guys in Australia Saturday, for guys in Europe Friday, Saturday. And so, we'll be back next week. We'll be covering our second part of this, which is now turned into a two-parter. And we will be also doing logging, and that will conclude 101 Live. So if you guys stuck through it the whole way, congratulations. And we'll see you guys anyway next week. All right, bye for now.